Ready.
Okay. All right, so let's talk about some strange stuff. And first of all, what is light? It's an electromagnetic wave, except it's not. What is electromagnetic field? Well, it is a combination of two things happening at once. It's a disturbance in a magnetic field and an electric field that travel perpendicular to each other. So what you have here is this is, say, like in the plane of the board, the magnetic field is waving in that direction, and the electric field is waving in this direction. And the trick is, unlike mechanical waves that require a medium to travel, electromagnetic waves need no medium to travel. How does light get here from the sun?
Through the vacuum of space.
Through the vacuum of space. Like waves, there's frequency and wavelength, and the differences in frequency we perceive as colors. For sound, the difference in frequencies is how high or low the sound is.
The frequency.
And so, and here what we have is the wavelength in nanometers. 700 nanometers, that's the longest wavelength, and 400 nanometers is the shortest wavelength, and that's the visible spectrum that our eyes are sensitive to. However, the electromagnetic spectrum is a wide range of frequencies, wavelengths above and below human perception. What have I done here? Have I moved it? Yes, I have. Get it back over where it belongs. There you go. And you're familiar with this. So you have the spectrum from long wavelength to short wavelengths, from low frequency to high frequency, and radio waves. That's what our cell phones, cell phone's not a phone, it's a radio, and with a computer attached to it. The microwaves, this is a microwave oven. There's infrared. That's the stuff that mosquitoes can see, the way they can find you at night in bed.
Oh, tricky little suckers.
It's heat.
Oh, I'd be glowing.
You glow, and so they find you. Ultraviolet is shorter wavelength. X-rays is shorter wavelength, and gamma rays are, and so
that's where
also
we hang
there's
out.
an increase in energy. The lowest energy are radio waves. The highest energy are X-rays and gamma rays, and these are ionizing radiation. At the higher frequencies, the higher energy, they can knock electrons out of atoms.
I love that unit in chemistry.
Yep. The speed of light is such an important velocity that it has its own symbol, and that's the letter C. 3 times 10 to the 8 meters per second. It's a universal constant. It is a universal constant. And the speed of light is the wavelength times the frequency. Now this C is the same speed of light, the same symbol that's in Einstein's famous equation. E is equal to mc squared. And it's the energy mass equivalency. And it tells you that there's a lot of energy stored in mass. Okay, light is strange stuff. Sometimes it behaves like a wave, but it's actually a particle called a photon. This is the particle wave duality.
Yeah.
Okay, the energy of a photon depends on its frequency. Well, wait a minute, you just said it's a particle, but it has no amplitude. Photon has no amplitude. It's sometimes referred to as a packet of energy. A photon is a packet of energy.
That's how I describe it.
Yeah, and so light is bright or dim depending on how many photons.
More photons, more
Sound is quiet or loud depending on the amplitude, the pressure difference between high pressure and low pressure. There is no amplitude with light. It's you have more photons or less photons. Dimmer, 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 less photons. And what we're going to be studying is geometric optics. It makes an assumption that light travels in straight lines. Okay? And light does travel in straight lines. You know, you can put your finger here, there's a straight line between your finger and whatever you're looking at, and at our scale that is true. However, individual photons, the path cannot be predicted. And in fact, Heisenberg uncertainty principle
Yeah.
kind of applies here.
Yeah.
So
that's what I was thinking about.
this is